Today we're going to learn about a type of transformation called a translation. A translation is sometimes called a slide, even sometimes called a shift. So you should know that those words all mean to do the same thing. Translation is just the very technical term for all those, the technical math term that is. And it is a movement of a figure from one position to another without turning it. In a translation, every point on the original figure is moved the same distance and same direction. The image is congruent to the original figure. So hopefully you remember that the word congruent means exactly the same shape and size. A translation rule is written as x plus a, comma y plus b, with a and b showing the horizontal and vertical shift. So a is our horizontal left and right shift, and b is our vertical up and down shift. So we're going to start with doing some graphs together. For number 1, we're going to go ahead and graph M0, 0. And as we're graphing, we need to label each point with its corresponding coordinate. A, negative 6, 0. T, negative 7, 6. And H, negative 1, 6. I know yours says negative 8. Go ahead and change that negative 8 to a negative 1. And then neatly connect the points using a straight edge. I have to do my best without a straight edge here. To reveal a trapezoid. So now we're going to slide. Again, remember slide is a word for translate, which is a type of transformation on a coordinate plane. So we're going to slide or translate math to the right 5 units and down 1 unit, which is noted in the rule x plus 5, y minus 1. So this we could also do mathematically. And when we go ahead and do the translation, instead of labeling the coordinates MATH, we're going to label them what's called M prime. It's just an apostrophe, but for math, we call it a prime sign. A prime, T prime, and H prime. So in this case, we could do the math. If we do 0 plus 5 and 0 minus 1, we get 5, negative 1. If we do negative 6 plus 5, we get negative 1. And 0 minus 1, we get negative 1. If we do negative 7 plus 5, we get negative 2. And 6 minus 1, we get 5. And then if we do negative 1 plus 5, we get 4. And 6 minus 1, we also get 5. So those are going to be the coordinates of our translated shape math prime. We could also do it just by counting coordinates. So M is being shifted 5 to the right and down 1. So 1, 2, 3, 4, 5, down 1. Labeling it M prime. A is being shifted 5 right and down 1. 1, 2, 3, 4, 5, and down 1. A prime. T is being shifted right 5. 1, 2, 3, 4, 5, and down 1. Label it T prime. And H is also being shifted right 5. 1, 2, 3, 4, 5, and down 1. Label that H prime. And then neatly graph your shape with your straight edge. And you can see that this trapezoid, our blue trapezoid, is exactly the same size and shape as our green transformed trapezoid. The top part is 4 units long. Top part of this green one is also 4 units long. The bottom part is 6 units long. The bottom part of our green one is also 6 units long. And their heights are the same as well. They're both 6 units tall. So we've gone ahead and translated this shape from math to math prime, creating a congruent shape on a different place in the coordinate plane. So we're going to go ahead and do number 2 together, and then you're on your own. Graph RULE. R is at 0, -4. U is at 4, -2. L is at 6, -4. And E is at 4, -6. Take your straight edge and neatly draw your shape. And we see we have something that kind of looks like a kite on its side. So now we're going to go ahead and slide or translate. Remember, translate is the technical term for a shift of a coordinate, that type of transformation of a shape across a coordinate plane. So we're calling it a translation, even though in the directions it says to slide. So remember that technical term, translation. So slide rule to the left 6 and up 8, which is the same as x minus 6, y plus 8. So we're going to do the math first again. We have r prime. It's really important that you put a prime sign next to the one that has been transformed. So if we do 0 minus 6, we get -6. If we do -4 plus 8, we get +4. Then u prime. 4 minus 6 is -2. And -2 plus 8 is +6. L prime. 6 minus 6 is 0. And -4 plus 8 is +4. And E prime is going to be 4 minus 6, which is -2, and -6 plus 8, which is going to be +2. We're going to go ahead and graph those, and again, we could do it just by counting. So if we have this R, starting with R, we're going to go to the left 6 and up 8, so we count over 1, 2, 3, 4, 5, 6, then up 8, 1, 2, 3, 4, 5, 6, 7, 8, which is the coordinate we found before, and we label it R prime. Next one, -2, +6. So we go again, starting at U, left 6 and up 8. 1, 2, 3, 4, 5, 6, and up 8. 1, 2, 3, 4, 5, 6, 7, 8, which gives us the point -2,6 that we found earlier. U prime. L, again, counting left 6 and up 8. 2, 4, 6. Then up 8, 2, 4, 6, 8. And last, we have to move our E to the left 6, 2, 4, 6, and up 8, 2, 4, 6, 8. Labeling it E prime. Neatly graph your shape. And we should have a congruent shape to the original rule. And again, if you look, just looking at the blue one from V to E, it's 4 units apart. V to E is still 4 units apart here. If we're looking from R to L was 6 units apart, and R to L up here is also 6 units apart. So all we have done is taken the blue shape and transformed it by translating it across the coordinate plane to create a congruent shape, rule prime. So you guys are now on your own. Go ahead and answer the rest of the questions in today's notes. We will be around to help you out, of course.